Now, in a scalene triangle, the smallest angle is 2/3 the size of the middle angle, and the middle angle is 3/7 the size of the largest angle. Find the measure of all three angles. Alright, so I'm going to draw an obtuse triangle, like so, and I'm just going to rank them in order. Would everybody agree that's the largest? I say that's the medium angle, and that's the smallest angle. Is that okay with you guys? Alright, now, the smallest angle is 2/3 the size of the middle angle. So, smallest angle is 2/3 the size of M. Is that okay with you guys? And the middle angle is 3/7 the size of the largest angle. Middle angle is 3/7 L. Alright? Which letter is the most important letter in this? It's got to be M. Why is it M? It relays the information from smallest to largest. It's in both of them, isn't it? So I want to get, so it's not too bad here. I can replace S with what? What can I replace S with? 2/3 M, yeah? I'm going to isolate L on its own. So L is going to be 7/3 M. That's L. And then we can just add them all together. And I think we're good to go now, aren't we? So M plus 7/3 M plus 2/3 M. 7/3 plus 2/3 is 9/3 M, which is 3M. 3M plus M is 4M. 4M equals 180 degrees. Implies that M equals what? What's that? 45 degrees, yeah? So M is 45 degrees. Now what's 2/3 of M? Anybody? 2/3 of 45 is 30 degrees, so that makes that 30 degrees. And then 7/3. Actually, I don't even have to do that because I can just add them up and take them away from 150. Or 180, I mean. So what you get? 105. Is that alright? Okay guys, you ready to move on? Okay. 3 times the width of a certain rectangle exceeds twice its length by 3 centimeters. And 4 times its length is 12 more than its perimeter. Now find the mass of Pluto. Now find the dimensions of the rectangle. Okay. I need to draw the rectangle, otherwise I'm not going to be able to answer this. Alright. W, L. 3 times the width exceeds twice the length by 3. 3 times the width equals 2L plus 3. Agreed? Alright. 4 times the length is 12 more than its perimeter. Now, what is P? Anybody tell me what P is? What is the perimeter? It's L plus W plus L plus W. So perimeter, which is this part here, is 2L plus 2 W plus 12, yeah? I think we're just getting a simultaneous equation here. Alright, I think the simultaneous equation we're going to get is minus 2W, bring over to 2L, plus 2L equals 12. And this one here is 3W minus 2L equals 3. I'm about to get W equals 15. And if W equals 15, then I have to figure out what L is. So if W is 15, what's 3 times 15? 45. 45 take away 3. 42 plus 2L, that means L equal 21. Everybody happy with 21 and 15? Okay, let's move on. It's just wordy more than anything, isn't it? It's just a bit wordy. Alright. Anybody know the trapezium formula? It's in your tables.
A plus B over 2 times B.
Yeah. So A is the top one. B is the bottom one. H value.
You make it a rectangle.
Huh?
You make the trapezium a rectangle.
You make the trapezium a rectangle.
Yeah.
And do two triangles. Does it say it's symmetrical? The trapezium doesn't have to be symmetrical. Oh, sorry. I had the exact same idea you had, by the way. Right? Exact same idea. So what Connor reckons is you drop it down like that, is it? And it's symmetrical. So if you imagine that's 7 aside, yeah.
No, I drop it like the other way, like from the corner up.
So which way do you drop it?
The bottom left corner up.
The bottom left corner upwards.
Yeah.
Like this.
Yeah, and then
I made a bigger made a bigger rectangle.
yeah, you can get that length.
But then how'd you take away the two? How'd you take away the two triangles?
Okay, that's 4 centimeters. That's like 4 centimeters. And then you got the.
That's 4 and that's 4.
Yeah.
So yeah, that's fair enough. That's a perfect method. You're treating that as symmetrical, then, aren't you?
Yeah.
All right. Trapeziums, to my knowledge, I don't believe they have to be symmetrical. So I believe that's a trapezium. But look, in a case where you're doubting it, just have a. So lads, Connor's prediction that they're symmetrical is true, purely because the slant lengths. See the two slant lengths of 5, because they're about the same. It means that the fall is the same. It means they're congruent triangles, which means the two lengths are the same. Okay, so we can use Connor's method for this, no bother then. So Connor's method is going to be making a bigger rectangle, and the size of the bigger rectangle is we don't have the what's it called, the height of that triangle though, do we? Yeah, we do, Pythagoras' theorem. Alright, so this will be 4, that's 4. We call this H and we call that 5. Is that right? Is it a 3, 4, 5 triangle? 5 squared equals 4 squared plus H squared. 9 equals H squared. H equals 3. You know the height of the rectangle is 3. Okay? So you have a big rectangle of 3 times 14. What's 3 times 14? 42 centimeters squared, alright? Now next thing you can do is you can figure out the area of both triangles. It's a half base times height, so a half 3 times 4, which is 6. And then just take away the 2. What's it, take away the 2 6s, is it? What happens when you take away the 2 6s? Take away 12, you get 30. Second method for doing it, which I think is probably the more common method, is most of you probably looked up the Trapezium Formula, and you figured out that the H value is 3, didn't you? And area equals what's it, A plus B over 2 multiplied by H. 6 plus 14 is 20. So it's 20 over 2 multiplied by the height, which we now know is 3. That'll also get you an answer of 30. So whichever one you want to do. We good? Okay. Now, this looks fantastic. A composite design of regular polygons is shown. Find the sizes of the angles alpha, beta and theta. Okie dokie. I suppose I'm probably going to do a bit of drawing. This is what I'm thinking. Okay. What type of triangles am I dealing with here? What do you reckon? Yeah. I can't for the life of me remember if they're... oh yeah. And that is, how many angles do I have in there? Is it 8? Alright, so then we're good. That's 360 degrees, isn't it? So then what's 360 divided by 8? Anybody? So what you say? 45 a pop, yeah? Okay. Now, if that's 45 a pop, what do you reckon about the two blue angles here? 180 minus 45 is what? 135 divided by 2? 67.5? Okay. So I think we're starting to get places. 67.5, 67.5, 90 degrees for here, isn't it? And another 67.5 down here. What can we say about this circle? Has to add up to what? So why don't we do 360 take away the other few? 360 take away 90 take away 2 67.5s. And what do we get there? 135? Anybody else get 135? Alright. Now, I'm going to work my way into the hexagon now. And once again, center circle, anybody? 360 divided by 6. What are they? All 60s, okay? 60, 60, 60. Now, because we knew this was an isosceles triangle to begin with, it's now an equilateral triangle then, isn't it? Because there's 120 degrees left, which makes every single angle 60s. Everything's a 60. So what does that make theta? Oh, no you don't. So everybody happy with theta equals 120? Any questions thus far? Okay. Now, next thing I'm looking for is beta, which should be reasonably handy. Alright, so beta should be, that's another 60, that's 90, has to add up to 360. So 60 plus 60 is 120, 120 plus 90 is 210. That would mean beta is 150. Is that all you're asked to do? There is a second part, is there? Done. If the square has a side of 4 centimeters, find the area of the composite shape correct to one place of decimals. Oh, lovely. Only the square, right? Grand. We're all good, lads. Easy peasy. Ready for this? Okay. If you're doing this in a test, where would you start off? Start off with the square. What's the square? 4 times 4? 16. Are you cool with that? Is it meters or centimeters or? Centimeters, right? That's your square, yeah? Now, here's what we're going to do next. What we know here is I'm going to concentrate on this triangle here, which has an area of, what's that, 60 degrees, yeah? That's 4, it's a equilateral triangle. I'm going to use a half AB sine C, for those of you that remember any trigonometry. So what's that going to be? A half 4 times 4 sine 60. Have we got an answer for me? Alright, give me a sec, I'll see if we can do it. 403. Yeah, is that 403? Yeah, thanks. So each one of these triangles is 4 root 3. How many triangles do we have? How many of them is there? 6 of them. So multiply it by 6. We get 24 root 3. Now working our way into this one. This one might be slightly more difficult, okay? So what do we know about the angle again? What?
45 and
Yeah, 45. Sorry, this is 45 degrees, wasn't it?
Yeah.
67.5 and? Alright, if we zoom in on one of those triangles, and I'm going to draw a bigger version of it here, okay? We all agree the base is 4, don't we? Agreed? Is it an isosceles triangle? What happens when I cut an isosceles triangle right down the middle? It only works for isosceles and equilaterals. So what happens when I cut it straight down the middle? It's going to be 2 aside, isn't it? Agreed? What angle is this again? We ever agreed 67.5? So I'm basically finding the centre length, and then I'm going to do a half base times height. I'm sure there's another way of doing it, but this is the way I'm choosing. Okay? So here's what we're going to do. I'm going to use the right angle rule, and I'm going to use tan. Why am I going to use tan? Opposite over adjacent. So I'm going to use tan 67.5 equals h over 2. Would somebody be so kind as to give me 2 tan 67.5? Oh, I was wondering what the story was with that. 2 tan 67.5? What? 4.828. Yeah. Now I'm well capable of getting the area of this triangle. How do I get the area of this triangle now? Anybody care to tell me? 4 is the base and the height is 4.828. So you're going to do a half base times height. So Mick, will you sort that out for me? 9 point?
9.657.
Yeah, don't even round it off. What's it, 9.6?
9.65685.
Alright. Tell you what, Mick, we'll do it all in one go. How many triangles is there?
8.
Multiply by 8, all in one go, then we'll round it later. What you get?
77.25.
25? Add them all together for me.
It's 134.819.
819?
Yeah.
So 82.
By 2.1 decimal place.
8. Grand. Anybody else get that? Who? It's Jamie, was it? Alright. Oliver? Mm-hmm. No. Mick, you got it? Alright, guys. Challenging stuff though, isn't it? It's not easy. And every question is different, isn't it? It's very hard to get a rhythm. Like you're struggling, what do I do for this one? Very hard to get a rhythm. Okay. Show that the area of ABD to CBD is AD is to DC. Oh man. ABD is this one. And CBD is that one. Show that the area of the blue triangle to the green triangle is DC, AD is to DC. Alright, great. So, not going to lie, even as a teacher, when I see a question like this and the ratios, I'm not a fan of them, right? But lucky for you guys, you can sort of pick around it, all going well, if they make their decision, alright? But when you see something like that, generally speaking, they're quite hard, especially to do on the day. So, you just sort of go in and you start problem, like because I haven't looked at the solution ahead of time, currently racking my head through what way can I get an area of a triangle and compared to the other area of the triangle. They have a common side, don't they? What's the common side? Huh? Yeah, they have that as a common side, so that's critical that they have one common side, okay? Now does it give us any indication that it's a midpoint or anything like that, that D is the midpoint of AC? Doesn't say it, does it? Therefore it cannot be assumed, right? So it can't do that. Any way of proving any angles are the same? Let's work with that. See if we can make any angles the same. So if that's X, I think I have it now. I think it just came to me, right? If that's angle X, what's this one? Okay. Then if you use a half AB sine C, they have one common side and got it. Alright. Once again, it's just pure. The only way I can relate the information, it's just pure experience. I've seen something similar in the past, but never this question. So here's what I'm going for. A half AB sine C. Okay, and there's a reason I got a good feeling about this, because if you look at the size I'm about to use a half AD BD. So a half AD BD sine X. Is that okay with you guys? Then what I'm also going to use is a half, and what about the other triangle? A half BD, what's the other one? DC sine 180 minus X. Now, here's some good news for you, right? Sine 60 is the same as what? Can anybody tell me? Sine 60 is actually the same value as sine 120. Did you know that? Right? So if you put it in, sine 60 is root 3 over 2. Sine 120, also root 3 over 2. Then you're going, does that work for anything? Let's find out. What would sine 40 be the same as? Sine 140. Once the two angles add up to 180, they should be equal to each other. Check it out. Sine 140. Same. Now, if you guys didn't know that and you were trying to reach into your bag of tricks, your next protocol would be to do this. What's sine A minus B? Go to page 14 of your tables. Tell me what sine A minus B is. So what is it, lads? I believe it's this, but you should always check it up. Is that it? Yeah, oh, just the other way around as well. Yeah, we're good? Alright, lads, what do we replace A with? Replace A with 180 and replace B with X. Sine 180 cos X minus, what is this? Minus sine X cos 180. And what you'll find out is it's actually sine X. So, as I proved earlier, sine X and sine 180 minus X are essentially the same thing. So I can just replace that with sine X. Happy days. Now, it wants the area of ABD divided by the area of CBD. Happy days. And what's left over then? Bam, 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 bam. AD over BD. AD over DC. Was anybody able to do it unassisted last night, or it's very difficult? Right? That was very difficult. Found that challenging. Okay. Now, ABCD is a trapezium. Prove that the area of C is the same as the area of D. Dang. All right. Once again, that's not looking good. All right. Let's see what I can pull out here. Okay. Which is all agree that angle X and angle X are the same thing. Why would I consider them to be the same thing? Huh? Vertically opposite, they're the same angle, alright? I've established that much. So if I'm looking for a temp marks, I could call this angle, point M, and I'll just go AMD equals BMC. Reason being is opposite angles, okay? Now, prove that area C equals area D. Now, does it give me any other information about them? Is there anything else I can conclude about the lengths? I have no indication that AD is the same length as. There's no indication that AD is the same length as BC, is it? Nope. Alright. So, I'm not going to waste your time. Let's go have a quick peek. I'd be stuck here. So what they're saying the following is, yeah, I think of this, I'm forgetting it. AB is parallel to DC. All trapeziums need two parallel lines, okay? That's great. Area of ADC, which is A to D to C. This one here, see the big one? So the big triangle here, they're saying that that one has to be the area, same area as BDC. So let's highlight that. So what they're saying is that this guy here, in blue, is the same area as BDC. It's the same area as this one in yellow. Now why are they saying that is what we need to figure out next. Okay, for two triangles to have the same, so anytime you get a obtuse triangle, like so, ready for this? If I say that's the height is actually outside the triangle this time. Why is it outside the triangle? Because it has to be vertical. So it's always the point directly down to the base, okay? And what they're saying is that they both have the same vertical height. That this triangle here has the same vertical height as this one here, okay? And they're saying their base lengths are the same. They both have a base length of DC, don't they? They both have DC and the same height, vertical height. So that's why the two of those triangles are the same. Same base and same perpendicular heights. Okay? Then what they're going to say next is area C plus area B equals area D plus area B, which is fair enough. And then they're just going to cross off both the area B's. I didn't see that. I wasn't going to get it. This is the answer to that. Okay? Just simply wasn't going to get it. Unless I've seen something recently to have me in that mode of thinking wasn't going to get it. Alright, is there a third part?
Yeah.
I'll come back to the third part tomorrow if that's okay. But